The next parameter is bus driver number. Each device on the intercom must have a different number. Rotating through the options with a spacebar, we see that the options are polar, polar/1, and the numbers 1 through 50. Any device can have any number between 1 and 50, but there can only be one of each number on the intercom. One and only one bus driver must be designated as the polar. The polar is the controller, and any bus driver can be set up to be the polar. If it's a small intercom system, less than 15 bus drivers, the bus driver can act both as a polar and as a station on the intercom, in which case you would initialize it as polar/1. With an intercom of more than 15 devices, you need a dedicated polar, which does nothing but act as the controller. We'll make this bus driver into the polar and a station. The next selection is name. The name can be up to 8 letters or numbers, but must begin with a letter. Except for units that you want to set up in a hunt or rotary group, each name must be unique. You can just type the name in. Set user level to 1 or 2. Level 1 users can connect and disconnect other users from each other and can even initialize other users remotely. Bus drivers destined for peripheral devices such as printers, plotters, and modems should be set for level 2. Competent PC users will want level 1. Baud rate refers to the data transmission speed. The bus driver must be initialized to send and receive data at the same speed used by the attached computer, and to send data into the serial port at the speed the port will expect. The baud rate has already been selected for this device. But if I wanted to move this bus driver to another device, I'd have to set it up for the baud rate of that device. Most printers are 1200, 2400, or 4800 baud. For choice of baud rate and the next two options, it would be helpful to find the manual of the device you're putting on the intercom, particularly if that device is a printer. Handshake is the process by which a receiving device stops and starts the flow of data from the sending device. Different equipment has different ways of saying, "Stop, I can't take any more data right now." Or, "Resume transmitting, I'm ready to receive more data." You must be sure that the bus driver is prepared to hear the right message from the attached equipment. Set PCs, printers, and modems to DTR. Also use DTR and serial to parallel converters. Some terminals must be set to X-off. If you're setting up a bus driver for a printer and you can't determine its handshake type, attach an RS-232 mini tester to the serial port of the printer or the parallel to serial converter attached to the printer. Toggle the printer's online or select switch. Using a mini tester is simple. Your installation guide contains a page on use of the mini tester. Bus drivers must be set to communications parameters which match their attached device. It's helpful to have the manuals for peripherals, which will be attached to the StarBus intercom. Look for the section that describes at what communication settings these devices operate and how they're changed. Setting the communication parameters on serial printers is usually accomplished from a series of tiny switches on the bottom of the unit, below the printhead, or beneath a small snap-away door. If a printer functioned properly before installing StarBus, it probably won't be necessary to change these settings. But by inspecting them, you can eliminate guesswork when initializing their respective bus drivers. Set parity to none and 8-bit data for use with PCs and most peripherals. Very rarely you may find a terminal or printer that requires 7 and 1. Set stop bits to 1. For a few older printers, you may need to reinitialize this parameter to 2. Set local echo to disabled. Leave line delay, disconnect character, and special character at their factory default settings. Timeouts can be set for anywhere from none to 1 hour. This means that if a user has not used the device he or she is connected to for whatever period you specify, the connection will be broken. Use timeouts of 5 to 15 minutes for modems and printers. Leave the buffer delay on the default. Press Ctrl-E to save these settings, then plug the bus driver into the peripheral or device for which it was just initialized. Then plug in the RJ11 telephone-style cord. That's all there is to it. Repeat this process for each device you want on the intercom. It's a good idea to label each bus driver as you initialize it so you'll remember where it's supposed to go. When you have all the bus drivers set up and connected, try out the intercom. All panel lights should be on. These lights provide diagnostic information. The bus driver is getting power. Your station is on the network and being polled for data. When data is being transmitted from your bus driver to another intercom, this same yellow light blinks to indicate that it has more data yet to send. The red light marked poll stays on to indicate that the bus driver is functioning properly and has successfully passed its power on tests. A flashing light indicates that this bus driver was initialized to be only a poller and not an intercom station. Complete information on the interpretation of these status lights is presented in the StarBus User's Guide. The network map provides another diagnostic tool. Now that the bus driver has been initialized, let's go to terminal mode. Press Ctrl A 3 times. The Control key is held down while the user types A slowly 3 times. Then press N and return. This displays the status of each bus driver on the intercom network. Connect and disconnect from some devices. Remember, if 2 devices didn't work before StarBus was installed, they won't work afterwards. But if they did work before, they will operate properly over the StarBus intercom. Expansion of a StarBus network is simple. Initialize a new bus driver and plug a 2-way splitter into an existing StarBus jack. You can expand and reconfigure the intercom even while it's in use, and without interfering with the system performance. Level 1 users can even initialize any bus driver on the network from their own PC or terminal. Connections, network maps, and initialization can even be performed from a PC at home or at another company with just a modem. Because the bus driver attached to the local modem behaves just as if it were attached to the distant PC, the StarBus data intercom provides remote diagnostics and initialization. For a complete set of commands, type H at the ACI prompt. If the bus driver is engaged in a connection or has not been used for more than a few minutes, you may need to awaken it. To do this, strike the A key 3 times while depressing the Control key. It's natural to be intimidated by change. StarBus was designed to minimize change and permit users to continue using their computers and terminals for those same functions and programs with which they've grown familiar. The principal difference users will notice is that they no longer need to interrupt their thoughts or leave their desk to access any peripheral or to exchange data with others. Suddenly, every device in the office is theirs to share. PCs, terminals, printers, modems, mini-computers, plotters. Making a connection is as easy as pressing the Shift keys or entering a 2-word command. Office managers will notice a difference too. While employees become more productive, the capital equipment budget is reduced. No longer must each user who requires a printer or modem have one idle on their desk. Now, customers can get maximum use of their office data equipment without the waste of time associated with waiting for printers or copying data onto diskettes to exchange files. And for the first time, office personnel will be able to transfer text files between dissimilar machines, like PCs, Macs, and PS2s. With built-in features like queuing for popular devices, print spooling, and hunt rotaries, StarBus will meet the future needs of growing companies.